You know that stomach-dropping feeling when you're watching a massive live event, say a tied game in the fourth quarter, and suddenly the screen just goes black?
Oh, the absolute worst. I mean, it's the ultimate live broadcast nightmare, right? It's just dead air.
Right, exactly. And preventing that panic often comes down to this little piece of hardware about the size of a coaster. So, welcome to this deep dive. Today, our mission is unpacking exactly that. It's a highly specialized piece of broadcast equipment from HDTVSupply called the AJA IPT-10G2-SDI Mini Converter, which, yeah, it's an $1,825 box that essentially just keeps the broadcast world spinning.
It sounds incredibly niche, I know, but its core function really represents a massive shift in how we handle video. Like, it takes a traditional 3G-SDI video signal and converts it into this highly efficient IP transmission using the SMPTE ST2110 standard.
Okay, wait, let's unpack that a bit because SMPTE ST2110 isn't just, sending a standard video file over the internet.
Yeah.
Older formats used to bundle video and audio and metadata all together into one heavy package, right?
Right, exactly.
But ST2110 actually separates them into distinct, independent IP streams.
Yes, and that is the brilliance of it. By breaking the signal apart like that, you get this incredible efficiency and flexibility on the network. You don't have to unpack the entire video file just to tweak one audio channel.
So it's less like upgrading a basic phone line and more like taking a massive physical freight train of data,
Yeah.
vaporizing it into individual components, and then beaming it through a digital pipeline to be reassembled instantly on the other side.
That is a great way to put it.
Okay, but here is my hangup. Almost $2,000 is pretty steep for what is essentially an adapter. I mean, why do broadcasters desperately need this specific box instead of just using standard network cables?
Well, because standard networks drop packets all the time, which causes buffering. Broadcasters obviously can't buffer live TV. So that brings us to the standout feature of this device, which is called hitless switching. It uses another standard called ST2022-7. If you look at the back of this unit, it actually has two massive 10 gigabit network ports.
Wait, hitless, does that just mean it has a really deep memory buffer, or is there actual duplicate data being sent?
It is actively sending identical data down two completely separate physical network paths at the exact same time. So if someone, say, trips over a cable and cuts path A, or a router reboots on path B, the receiver doesn't even flinch. It's instantly pulling from the surviving path.
But how does the receiver know how to stitch that together without dropping a single frame of video?
Right, so every single packet of data is stamped with a precise sequence number and a highly accurate timestamp.
Oh, wow.
Yeah, so the receiver constantly reads both streams. If packet 402 is missing from stream A, it just grabs packet 402 from stream B, aligns them perfectly using those timestamps, and outputs a flawless picture. The viewer never sees a glitch.
That is a staggering amount of computing.
Yeah.
I mean, it's aligning dual 10 gigabit streams of 10-bit video, plus up to 16 channels of embedded audio.
And running complex web-based controls.
Right, all in real time. Processing all that data simultaneously must generate massive amounts of heat. So does this thing sound like a jet engine?
You'd think so, but that is exactly where the engineering philosophy of this device really shines. Because despite the massive computational load, it is completely fanless.
Seriously, no moving parts at all.
None whatsoever. Designing a fanless, high-processing unit is notoriously difficult, but for broadcast engineers, it's non-negotiable. If you have a whining computer fan kicking on right next to a news anchor's microphone or strapped to a camera operator's rig, the whole audio feed is ruined.
So it has to be entirely invisible to the production.
Exactly.
Yeah.
And rugged. Because there's no fan vent, the internal components are way better protected. Broadcasters take these out into remote locations all the time, so it doesn't even need a standard wall plug. You can run it entirely off battery power using a D-tap cable.
Right, which taps directly into the standard power output on professional camera batteries.
Spot on.
So when you strip away all the acronyms and specs, what this really means for you watching the Super Bowl at home is that you are relying on an invisible safety net. This AJA Mini Converter isn't just an expensive cable adapter, it is a critical, heavy-duty insurance policy.
Yeah, the next time you watch a perfectly seamless live sports event or a breaking news broadcast, you'll know it's being held together by silent, zero-fail network fail-safes just like this one, catching network glitches before they ever reach your screen.
Which brings us back to that stomach-dropping feeling of a black TV screen. If broadcast engineers have perfected this level of instantaneous, hitless transmission to ensure our video streams never ever glitch, it makes you wonder, what other fragile digital systems in our daily lives desperately need this kind of invisible, zero-fail redundancy?